Hey everyone, it's Coding with Kareem, and today I want to make a video on the Asyncio library. The Asyncio library allows us to write asynchronous code in Python and gives us access to an event loop, so we can write asynchronous code similar to how you may do so in JavaScript with the async and await keywords. However, things are a little bit different in Python. So before we spend time looking at the Asyncio library and importing it, let's look at a synchronous example that we will try to mimic in the async file so that we can have a comparison of the two. So we have our program entry point, the main function, as well as the task function. This task function takes in a string as a task, and it also takes in a duration. And depending on what we pass in as the duration, this will be passed in into the sleep function, and this will inevitably halt execution in this function and block the main thread. So as you guys can see on line 13, 14, and 15, we are calling the rest three times. And on each time, we are passing a duration of 1, 2, 3, respectively. So you would kind of expect this to run top down, right? While task A is firing, the main thread will be blocked. So one thing to keep in mind is that because this is a pure synchronous example, while code is stuck in the sleep call, nothing else can run. So maybe if you had a web service running and for whatever reason there was code that ran sleep, that would block the main thread, so nothing else could fire. I just want to point that out because that will be different when we look at our asynchronous example. Let's actually run this file and let's see what we get. It should be straightforward, but I feel like it's good to visualize it. So we get task A started, finished after a second, task B started, finished after 2 seconds, and task C started, finished after 3 seconds. The total time elapsed was 6 seconds, so it kind of ran top down, which is what we kind of expected. So this is a pure example of synchronous code, right? Nothing asynchronous happening here. Let's take a look at the async file now. And in this async file, we are kind of doing something similar, right? We have this tasks function and we have the main function, which is our entry point. I also do have this welcome function, and I only wrote it to demonstrate that in Python, when you use the async keyword in a function declaration, similar to how in JavaScript, when you do so, when we add the async keyword, we're actually saying that we're returning a coroutine. Similar in JavaScript or Node.js, when you use the async keyword, you're saying I'm returning a promise. So this is just common syntax, and of course we can only use asynchronous code or await asynchronous code in an asynchronous code block, which is why our main function is also async. Just something to keep in mind. So I guess the more important code piece to look at is from line 21 to 24. As you guys can see, we're running task three times, but instead of just running on its own, we're actually passing in each one of these coroutines, because each one of these will inevitably result to a coroutine into this asyncio gather call. And what this will do is run all of these coroutines concurrently. So we don't necessarily have to wait for one task to finish for another one to fire. So if you were to visualize this, you would expect this to take no longer than 3 seconds, right? Because by the time task C finishes, you would expect task A and B to be done. But instead of making assumptions, let's actually run this file and let's see what we get. So as you guys can see, we get, so we actually get task A, B, and C started before 1 second even passed. So this is kind of already proving to us that this is running concurrently. And then as you guys can see, we get a total time elapsed of 3 seconds, right? That makes perfect sense because by the time task C finishes, task A and B have already done, because this whole code block is kind of happening concurrently, right? So this is an example of doing something um, concurrently. Now you may ask, hey, like I thought the sleep function blocks the main thread. Why is this happening? Well, we're actually using the sleep method from the Asyncio library and we're awaiting it. So using the Asyncio library, we get access to the event loop, right? And because we get access to the event loop, we can kind of write code like this and we can await it and we can expect it not to be blocking. One thing to note though is that as you guys can see, this main function had to be async. So our program entry is essentially an async function because you cannot use the await keyword in a non-asynchronous function. Because of that, you will have to wrap your asynchronous code. Excuse me, everybody. You will have to wrap your asynchronous code in this asyncio.run method call. And what this essentially represents is our program entry point for an asynchronous program, right? So if you have asynchronous code running, it needs access to an event loop, right? And it needs access to its own kind of environment. And the asyncio.run method gives us access to that. We wouldn't just be able to call main. Without this, right? So just something to keep in mind. Lastly, I want to take a look at a kind of maybe not a real world example because you probably won't find yourself doing this, but how we could kind of use some of these libraries in principle, right? So we have the two functions here. We have run sync and we have run async, right? For the run sync, we're going to iterate 40 times. So request count represents 40, has a value of 40. So on each iteration, we will be using this request library. This is not a part of the standard library, as well as the AIO HTTP library. That's also not a part of the standard library. So you will have to import those or install them from pip. But we will be making 40 GET requests, and each one of those GET requests will be synchronous. So one will have to finish firing before the next one fires. So let's actually call this code. So let me uncomment this async block here. As you guys can see, like you can't really run asynchronous code without running async run. But for synchronous, you can. So let's actually run this file here. Let me get the terminal queue. Let me clear it. Okay, great. So one thing to keep in mind is that we're making 40 GET requests, and we have to wait for each input-output operation to finish. So this may take a little while, right? This is not something you would want to do in principle, but it kind of shows how tedious this may be. If for whatever reason, you did want to make a bunch of asynchronous requests, right? Or I'm sorry, a synchronous request. That would take a long time. So as you guys can see in the terminal, that took virtually 20 seconds. Why did it take 20 seconds? Well, we had to make 40 input-output operations, and each one of those needed to finish firing for the next one did. Um, However, in this run async function, we're doing something a little bit different. So using this AIO HTTP library, we're actually creating a client, and through this HTTP client, we can actually kind of make requests concurrently without having to wait for them to fire, and it will not block the main thread. So we declare a tasks array. So we essentially drop a bunch of coroutines within this array, and then we pass in the list of coroutines into this asyncio gather method, which is precisely similar to what we saw in the async example, as you guys can see. That's why I chose this. So this is just an example of us running tasks concurrently at the same time. So instead of making 40 GET requests synchronously, we're going to be making 40 GET requests concurrently, right? So the requests won't care that one didn't finish or not. They're all kind of doing their own work. So let's actually comment out this synchronous example, and let's introduce our async code. And let's run this file. And wow, so that didn't even take 30 milliseconds. That took um, half a second. That's pretty fast. Well, we just made 40 GET requests. In principle, we did the exact same amount of work. However, one took 19 or 20 seconds and the other one took half a second. Well, why is that? Well, on this asynchronous example, we're using the power of the event loop to kind of make these HTTP requests non-blocking, right? So we can make an input-output operation and we don't have to stay there stuck. Some other part of our code base or some other thread in our program can go initiate another HTTP request. And that's essentially the power of using the await keyword. When we use await, we essentially give power back to the event loop. However, something to note that when we talk about the event loop in Python, you have to realize that Python does not by default have one. It is a synchronous kind of programming language in that sense, which is why we use the Asyncio library. When we use the Asyncio library or the Starlet library or like Fast API, they already implement an event loop in the background that allows you to run asynchronous code. This would be a little bit different compared to like a runtime like Node.js, that's inherently kind of like input output based. We're going to make sure we support all asynchronous operations. You really don't even have to think about it too much. Just learn how to use the async and await keywords, and you should be good. However, in Python, you do have to think a little bit more of, hey, where am I in this asynchronous code block? And do I have an event loop? Where can I get one? And using the Asyncio library, as well as using the AIO HTTP library, we're also we're able to kind of write asynchronous code in Python. So that's essentially a lesson. That's essentially the gist of using the Asyncio library. If anybody does have any questions, or if you feel I didn't explain something very well, I do have some bad habits, please feel free to let me know. I'd be very, very happy to answer anybody's questions or maybe make anything more clear. I will drop all my code in the description. It should already be pushed into my GitHub repository, but I'll link that repository so you guys can hopefully clone the code base or clone the repo and also kind of run this as well. Just one thing to note is that right, the request library in the AIO HTTP library does not is not a part of the standard Python um, library, so you will have to install it using pip. And because of that, I am making a virtual environment because I don't want these things installed globally. So if you want to make a virtual environment, feel free to do so. If you don't, that's fine as well. If you need any help, feel free to let me know or ask ChatGPT. I'm sure they'll be happy to help. I hope you guys have a great day, and I'll talk to you guys soon. Bye bye.